by a single term. This time we're going to divide by a binomial, which let's break that word down. That means two terms. Okay, we talked about trinomials with factoring. A binomial is two terms, so that's referring to, in this first case, that h minus 2. That's what we're dividing by. It's two terms. We use something called synthetic division. It's called synthetic division because the word synthetic means that it's like a substitute for something. If you think about a synthetic material, it's not cotton, it's some other kind of material, but it serves the same purpose. So this is not true division, but it serves the purpose. It completes the process, and it's a whole lot easier. So the first thing that we always do is we take what we're dividing by and we set it equal to 0. So I already have that set up on your paper. We're going to solve for the variable. So in this case, to get the variable h by itself, we need to add 2 to both sides. So that says 0 plus 2 is 2, so h equals 2. That number goes on that backwards L that I have there on your paper. That's what we call the shelf. Put it on the shelf. Beside the shelf, we are going to list all the coefficients that are in the bigger polynomial. So the 4 is going to come down. The negative 7, if there's a minus, you have to include that as a negative. And then minus 2, so that's a negative 2. Leave yourself some space between these numbers. You do not want these numbers running together, because it's a very easy process, but if you do not keep it organized, you're going to mess something up, okay? So make sure that you keep it organized. So that's the setup. Any questions about where I got my numbers from or anything like that? Okay, now let's do the process. First step of the process is we always bring that first number down below that line. So the 4 comes down. Now we multiply the number that's under the line by the number that's on the shelf. Now, we will get to a point where I will not write this right here, but for right now, I encourage you to do that so you know where these numbers came from. So the number that was under the line, we multiply it by the number that's on the shelf. That is 8. 4 times 2 is 8. We are going to add negative 7 plus 8, and we get positive 1. That result goes under the line. Then we repeat the process. Multiply the number that's under the line by the number that's on the shelf. So 1 times 2, and that is 2. And so then we add. Negative 2 plus 2 is 0. The last number, when you get to the end of the line, the last number, you always box in that number. Yes. Negative 7 plus 8. Okay. We always box that, and that is our remainder. That's the remainder to this problem. You remember, anytime you do division, it either divides evenly or it does not divide evenly, and you have a remainder. So in this case, we've got 0, so that means it divides evenly. Now, we just have these two random numbers. We've got a 4 and a 1, but our problem had variables. So what we do is we look at the degree of the original problem. In this case, it was degree 2. We reduce the degree by 1 because we have divided h squared by h. So it goes from h squared to just h. If there's not a sign in front of a number, it's a positive number, right? So that means that's a plus 1. Okay, so what this means is the original expression here, 4h squared minus 7h minus 2 divided by h minus 2 equals 4h plus 1. Okay, That's what it means. When we divide this quadratic by this linear factor, the result is 4h plus 1. You can check by graphing. You plug in the left side, you plug in the right side. It should be one graph. And what I mean by one graph, while you're writing that, I'm going to go ahead and type this into Desmos. So we type in our equation. Don't use h. Remember, we always want to put in x's. Okay, let me show you what I'm doing right here. Okay, I'm typing in that original problem, and then I'm typing in my answer. Okay, notice right now I see two different lines. When I finish typing in my answer, that +1, all I see is one line right here. And if I make it disappear and reappear, I can see that it's in the exact same place as the other graph. If they are the same graph, in this case lines, then that means that these two expressions are equal to each other, which is what it's supposed to be. Okay, they are supposed to be equal to each other. If you had messed up a sign, if you had said that that was a -1, okay, notice if I type in 4x minus 1, these are two different lines. So that means I messed something up in my synthetic division. I need to go back and check because those two things are not equal to each other, which they should be. Okay, I'll point that out again here in a minute when we do another example. Any questions so far? Okay, flip your paper over. Let's look at a couple of different scenarios. The process is still the same. Nothing has changed about the process. There are just a couple of details that I need to point out. Okay, so let's do top left corner. We're going to do that problem. We take what we're dividing by, set it equal to 0. So x plus 8 is equal to 0. Solve for the variable. Subtract 8 from both sides. So we get x equals -8. And -8 goes on the shelf. We bring down the coefficients. If there is not a coefficient in front of a variable, what is it understood to be? 1. Okay, so that x squared, we put a 1 right there. Then we get a 3 and a -43. Hello. Okay, 1, 3, -43 are our coefficients. Okay, leave yourself that space, draw your line. Don't lose the negative, okay. Bring down the first coefficient. Always, always, always that first coefficient comes down. Bring down the 1. Okay, we multiply what's under the line by what's on the shelf. So 1 times -8 is -8. We are adding 3 plus -8. That gives us -5. Multiply the number that's under the line by the number that's on the shelf. -5 times -8 is +40. Add -43 plus 40. That's -3. That was our last number, so we box it in. So we didn't get a remainder of 0 this time. That means that did not divide evenly because we have a remainder. We started with x squared, so we've got an x right here. We've already got the minus sign. Here's how you need to write this answer. X minus 5 plus the remainder over the divisor. Now, let me relate this to long division from way back when. Let's say that we're dividing 29 by 3. Okay, dividing 29 by 3. 3 goes into 29 how many times? 9 times. Okay, 9 times 3 is 27. We subtract, we get 2. 2 is the remainder, so 9 2/3 is equal to 29 divided by 3. Okay, we took our remainder, we put it over what we divided by. We're doing the same thing here. We take our remainder, we put it over what we divided by. That's why we do that. You can check it if there's a remainder as well. Okay, you plug in the original problem. Okay, here's the original x squared plus 3x minus 43 over x plus 8. Here's our answer. Okay, and it's the exact same graph. Okay, there's no difference. If you want to zoom out so you can see a little bit more, that's fine. But it is the exact same graph, so you know that you did it correctly. Again, if you messed up a sign somewhere, say you didn't have that negative, okay, notice these are not the exact same graph. They're close, but they're not exactly the same. So that's what you're looking for when you're plugging into graph to check. You may also see whenever the remainder is negative, they might also write it this way. Instead of adding it, adding a negative is the same as subtracting 3. Okay, adding negative 3 is the same as subtracting 3. So those are the same. You will see it this way on the answer key. You'll see the minus on the answer key, not the plus the negative, but it's the same thing. Okay, let's do one that starts with a cubic function instead of a quadratic function. Again, nothing's changed. It doesn't change anything. There's just some details we need to talk about. Y minus 2 is equal to 0. Solve for y. So we add 2. 2 goes on the shelf. We've got another coefficient of 1. Then we've got 5, negative 7, positive 2. Okay. Bring down the first number. Bring down the 1. 1 times 2 is 2. 5 plus 2 is 7. 7 times 2 is 14. Negative 7 plus 14 is positive 7. 7 times 2 is 14. 2 plus 14 is 16. That's the remainder. We started with a cubed, so we reduced that by 1 degree. A squared, 7 is positive. Then we have the a, and that other 7 is positive. So our final answer, a squared plus 7a plus 7 plus 16 over our divisor. Why do I have a's and y's? I just realized that I have 2 different variables here. Okay, let's make that first one a y. I did not notice that at all second period when I did these. These should be y's. I have no idea why they're a's. I'm sorry. Okay. Y squared plus 7y plus 7 over 16 over y minus 2. Really random. Okay. Not going to take the time to check that, but again, you can check it the exact same way. You put in the original, put in your answer, make sure they are exactly the same graph. All right, let's do another one with a third degree, but let's compare these two polynomials first. This is degree 3, but it has 4 terms. This is degree 3, and it only has 3 terms. What term is it missing? We've got k cubed. It's missing k squared. It doesn't have k squared. Now, normally, we don't worry about zeros whatsoever. But because of the way this process is structured, if you are missing a power, you must put a 0 where it should have been. And I'm on the Y train here. That should be okay. All right. So, process still the same. Okay, k plus 5 is equal to 0, so we subtract 5, so k is equal to negative 5. Negative 5 goes on the shelf. K cubed has a coefficient of 1. K squared was missing, so we must put a 0 there. negative 17, positive 32. Bring down the 1, multiply, 1 times negative 5 is negative 5. Add, 0 plus negative 5, negative 5. Multiply, negative 5 times negative 5, 25. Add 8. Multiply, 8 times negative 5, negative 40. Add, we get negative 8. Negative 8 is the remainder. We started with k cubed, so we've got k squared, k. 8 is the constant. So then we write our final answer. K squared minus 5k plus 8 minus, our remainder was negative, so just write it as minus 8 over k plus 5. Okay, one more example. It is on your paper, but if you'll notice, what you have on your paper looks a little bit different than what I have up here. I realized that I needed to modify it after I'd already printed the copies. So just look at the difference, okay? All the numbers should be the same, however, mine is out of order. Mine is not in standard form, meaning that the highest powered exponent is not listed first, okay? Everything else should still be the same. Now, the reason why I threw this up here is because there are some problems on the practice that your terms are not in order. Your terms must be in order to be able to do synthetic division. You do not necessarily just copy them straight down if they are not in standard form. Okay, so x minus 8 still set it equal to 0. We get 8. Okay, we've got to start with the highest powered exponent, which is x to the 4th. Its coefficient is 8. Then we go x cubed. That's negative 64. Then we do x squared. We don't have an x squared. We got to put a 0. Then we've got x. That's 3. And then our constant is negative 28. You always have to go down to the constant, meaning the number that doesn't have a variable. If you don't have one, then you got to put a 0 on the end as well. Okay, you don't have a constant, so like if there wasn't that minus 28 in this problem, we would need a 0 on the end of our synthetic division. All right, let's do it. Bring down 8, multiply. 8 times 8 is 64, positive 64. So negative 64 plus positive 64 is 0. 0 times 8 is 0. 0 plus 0 is 0. 0 times 8 is 0. Bunch of zeros there. Be careful. Not a 0 anymore. 3 plus 0 is 3. 3 times 8 is 24. When we add those, we get negative 4. Negative 4 is our remainder. Our degree was x to the 4th, so we start with x cubed, x squared, x. 3 is a constant. Now, we're not going to write those zeros in our final answer. 8x cubed plus 3 minus 4 over x minus 8. Okay. Now, we need it then in the process, but once you get to your final answer, if you've got zeros, you leave those out of the final answer. You don't need those anymore. Okay? Any questions? If you leave that 0 out of the original setup, it's going to throw everything else off, and your answer is not going to be correct. So you've got to look out for if there are powers that are missing, and you got to put a placeholder there in its place.